So I'm here to teach you all about BIM. The main purpose of this is to, I guess, share all of our available BIM tools that Sletten has and how project teams can best utilize them. So we'll start with a basic clarification of just exactly what BIM is. So you've probably heard BIM and VDC and CAD, and to a lot of people these are used interchangeably, but in a very technical sense, BIM and VDC, VDC encompasses BIM, but BIM does not include everything VDC does. So BIM will be more your 3D models and coordination using software, and VDC will also include reality capture and drone flights and laser scans. So Autodesk.com has a very long definition that is here for your viewing enjoyment, but bare bones, or basically BIM, stands for Building Information Modeling, and it's just creating and managing information for a building. So this is Sletten's BIM tool belt right here, looking at, and also on that table. So the first thing that we use is drone mapping, and on the table there we have our DJI Phantom as well as the Mavic Mini. The softwares that we have are Drone Deploy. We'll go over all of its features in the next slides. And the DJI Go Fly app, and that's going to be our remote controller for manual flights as well as requesting airspace when we're flying near an airport or hospital or correctional facility. And the main uses for these are photogrammetry and perimeter videos. And on Drone Deploy, you can actually take area measurements and volume measurements and use it to estimate your cut and fill on your site. And then the Mavic Mini will be more useful in interior flights that we'll go over in a little bit. So laser scanning is another very useful tool, and we have our Leica P40. I don't know that a lot of people appreciate that we have a P-series Leica. That is like a very expensive, state-of-the-art type of laser scanner. So, yes, making those. So has an awesome tool that so far since I've been here, the industrial division has used, but happy to help any projects that need a laser scan. Our software that we use is the Leica Cyclone Register 360 as well as Recap, and that'll get us between 3 to 5 millimeters of accuracy depending on how far apart your scans are, and then scan to BIM. So if we were going to do a TI and say the duct was going to stay, we could scan everything that was existing, put it in the point cloud, load it up to Navisworks, and then model around that and coordinate around it. And then of course we have 3D modeling, and our hardware is the BIM department's computers. The software that we have is the whole Autodesk architecture license. So most common is going to be Revit and Navisworks, but if you are like Merced, then I get to learn how to use Civil 3D and AutoCAD for underground utilities. So that's been fun. And then of course we're going to do building coordination through clash detection and issue resolution. And at the end you'll have a digital twin. So for drone mapping, on the right, the bottom two are pictures that were taken on the Phantom, and the top one is a potential use case for the Mavic Mini. So the interior flights that are possible with the Mini, it has propeller guards on it. You can just fly it around any building that might have like a hard to access area. We could put it up over this ceiling if we wanted and get pictures of there, or maybe more practical or useful might be in an elevator shaft before it's actually closed that has restricted access. You can fly it in there and get pictures of things you need. But the most common use case is with the Phantom itself, and that's the bigger of the two for site flyovers. You can do some photo maps, perimeter videos to track progress, and then stills of specific areas. So I'm gonna do a demo of drone deploy on one of our projects. I think this is St. George, and just show you all of the tools that how we can use drone deploy. So this map is Google Images, and then overlaid, you can kind of see the non-moving part is our photo map of our St. George project. So on the left, you'll see layers and media. So if we wanted, we could see an elevation view. It'll show us the terrain, colored terrain map from high to low. Our map photos will turn on. You can see our flight path. All these blue dots are individual pictures taken. If you wanted to view an individual picture, we just click on a blue dot, and then we'd see how it was all pieced together. Then this information will also give you your relative and absolute altitude and the date and time that it was taken. And then if we want to compare progress, say from August of this year to November of this year and what was different, we just use the slider to view what was done. So you can see, this basin was emptied and it's now currently under construction. And then you can also toggle these between any two dates you want to compare with. So we exit out of that. We can also toggle on and off annotations and issues. So on the right is the annotation and issue bar. So location is pretty basic. You just click that and you can place a pin and label certain areas of your job, like if you wanted to number the basins. So distance is one of the most useful tools because you can take I'll go back to our most recent flight, any distance that you want on a job from one point to another, and I'll just do the diameter of this basin. And it'll give you your length, horizontal length, surface length, and then a surface profile. So if you're not familiar with basins, they slope down towards the center, and then the point is about equal with the height of the edge of it. So this is actually really useful in calculating volume and area. So
accuracy.
Yeah, so it varies based on your GPS data, but this is within 6 inches accurate to itself. And then if you have a GPS base station, you can get it within a centimeter of its geolocation.
Okay.
So volume, you can take the volume of any area, and I'm just doing a quick rough circle here of this basin. We'll do all the math for cut, fill, net volume, material volume, and area. And so this is really useful. Matt Schumacher isn't here, but on the Zone North Reservoir, he had to clear bedrock from his job, and he told the owner and gave him the bill for all the quantities that they cleared, and they wanted to fight him on it and say, no, you didn't remove that much. He pulled up his drone images from last year and showed them the cut and fill volume of that area that they cleared, and then they paid it. So right there, it paid for itself. So in addition to volumetric, you can also do counts. So say you have a stockyard and don't want to send your project engineer out there. You can just click, and it'll count all of that. You hit check and you can name them PVC pipe or whatever you want to do. And then issues is also pretty similar. If you want to use this for safety application, and see somebody not wearing their hard hat, you can just pinpoint. But of course, he's not going to be there. So if there's like a pit and your perimeter has been compromised, like the safety tape kind of falls off, you can just mark it as an issue, title it whatever you want, give it a severity. So This is somewhat helpful for field management if would like to use it for that. But probably the most useful of tools is in the 3D model that it creates from the images. So they'll also save your issues and annotations in 3D when you look at it. So the drone takes a bunch of pictures and then we upload them to Drone Deploy. It uses photogrammetry to create a point cloud. And then it overlays those pictures on top of that point cloud. We just want the point cloud view to measure from point to point distance. It takes a while to get fully loaded, but you can see it there as it comes in. I'll turn off our annotations. The contours tool was actually added within the last month, so it's pretty new, but it's actually kind of useful to see just an elevation changes of your site. I mean, it's not survey grade per se, but the different contour lines that you can see show the elevation changes. And then of course you can have a colored 3D elevation map, and you can still view your map photos. And if it's in 3D, you'll actually be able to see the angle which the picture was taken. So and then export, you can choose from PDF, JPEG maps to point clouds, elevations, and then 3D models. So we've used a 3D model exported as an OBJ file, which can then be loaded into Navisworks. And actually on one of the middle schools, one of the owners was, well, I don't know what the word is, but they requested to have as-built model or actual, how it currently is, overlaid with what the new model of the middle school will look like. So they can see what will be demoed, what's existing, and how they'll interface. So, and we were able to do that with an OBJ model. So that's a brief overview of Drone Deploy and drones and all the tools that we have. And yeah, happy to answer any more questions you might have at the end or just whenever, you know, where my office is.
I have a question and you can answer right now, James.
Sure.
You went through a lot of features that Drone Deploy is capable of, but if a project manager wants to actually implement that on his job site, what are the steps? Like, we have the hardware, we have the drone, we have you to fly it and your time that can be charged to the job. But apart from that, what other investments does a team need to make to use it or apply it successfully? Is the software an additional cost from what we already have, or is it included? How does it work?
No, so all those tools that were shown are all included with our current license right now.
And more users, so if Brand wants an account for himself, he can get it.
Yeah, so if a job wants to have their own account, it's an additional $3,000 a year.
Okay.
But if they don't mind just password sharing with everyone else, then it's just the cost of drone flight. So thanks, Raj. All right. So for laser scanning, like I said, the P40, just some quick stats, 1,000,000 points per second. And it's about a 5-minute scan, so I'll let you do the math on that. The range is 270 meters for a single scan. And the accuracy you can get to up to 2 in a 50-meter scan and up to 5 in 100 meters between scans. So the United States Postal Service has a slogan that's pretty inspiring, and I'll just read it for your enjoyment. Neither snow nor rain, nor heat nor gloom of night stays these couriers from the swift completion of their appointed routes. So the BIM department has adopted that slogan too, but we've added nor sewage. And this is a picture of the secondary effluent structure over on the Clark County water sewage plant on the other side of Samstown. And I've circled it here. You can kind of tell But down there is that very Leica P40 system down in the sewer line. So luckily only the tripod got wet and, you know, Clorox wiped it and everything. But down there is Randy Norton and Tom and Colton are up top making sure everything's safe. But they needed to scan to measure the size of the wall-to-wall dimension to install a bulkhead. And while there's not an online viewer, I just added some screenshots so you can kind of see. And this is also a point cloud with the panoramic pictures overlaid on it so that you're able to measure from point to point and get an accurate distance measurement. And also happy to show this to you on my desktop computer in my office if you want to see its full functionality. And then another thing that this did is it pieced together all those points and made a 3D model from our scan. And so where the drone will get a point cloud that's accurate within 6 inches, this is just a single scan, so this is within 2 millimeters. And then in our tool belt, we had in blue everything that's available to us, but not Sletten done. So this can be rented for project teams, and this is a wearable laser scanner. So it does everything that one does. It has 5 millimeters of accuracy, and it's because it's wearable, you don't have to set it up and level it on a tripod every time. You know, if you were to scan in this demo, they did a 750 square foot room in 60 minutes with a terrestrial laser scanner. This one was 5. And so they actually came and did a demo at Zone North at the reservoir on the other side of town. And so I'll just go through briefly what we were able to capture. So there's me and the other Navis guy. And again, this is another point cloud with photos overlaid so that it's as if you're walking around it yourself. And here's all the points that it captured. So if we go to any one point, we can use our measurement tool to mark any distance or area from polygon or rectangle on the horizontal or vertical axis, or just any free distance. You'll also notice in these pictures, there's construction workers like working. There was a mobile ladder cart that was moving around. So that is a benefit of having a wearable scanner, is you don't have to stop construction progress or ask people to move out of the shots. And it's also, this whole scan took about 20 minutes. So it was very fast, and we still have that 5 millimeters of accuracy. So that is also an option for project teams. And finally, we have BIM modeling. So not every job has this in their contracts, but it kind of, oh, that's hard to see on the screens. Maybe look at the left TV. Not all the jobs have this written in their contract, but just as a brief overview, it's it can be thought of as like a 12-step process. I mean, I'm sure you could break it down or simplify it, but so from everything from creating a BIM execution plan to handing it over to the owner and all that in between. We'll set up file storage management on Viewpoint now, work with the architect to create that BIM execution plan, and then meet with project teams to create coordination schedules and set expectations. And we actually kick off our BIM meetings and lay out the schedule and tell them the LOD that's required. Number 5 is ideally one that would never have to happen, but every job there's scope gap in modeling. So like we mentioned with Merced, the civil was only contracted in 2D. So now I've gotten to learn civil 3D and model it, and then there was a bunch of design changes, and then we got to do it all over. And hopefully there's not any more, but who knows? Yeah, we'll see. So from there, we'll compile all the design files and the subcontractors files, put them into Navisworks, run clash tests, host coordination meetings, and send out NWDs with issue assignments and get them resolved. And then sometime down the road, we'll collect all the sign-off documents and hand over a completed model to our owner. So
How do these efforts on BIM make it to the guys in the field? And then what if there's a discrepancy between that 2D construction document and the whole coordinated on BIM?
yeah, so the 2D plans always rule. Like if there's a discrepancy, you always go with the 2D plans because that's what's in the contract. But ideally, I mean, you make the 3D plans based off of the 2D plans, or even architects will make their models in Revit and then export 2D plans from that. So if there is a discrepancy, I mean, usually it's because, you know, in 2D you can't see all the elevations and maybe something wasn't caught in that. But I mean, to answer your question, the 2D always rules, but I mean, so we model for coordination. We just make sure that it can be constructible and everybody has room.
And do you mostly model with a subs BIM team or with an engineer?
So the engineers are like the designers, and then they'll hand their models over to the subs on the contracts that we're working on right now. This is how it works. And then the subcontractors will populate it to a specified level of development, which is like whether or not they have hangars modeled, or whether or not they have the exact system or just a placeholder that's the same size as that. And then from there, so we won't coordinate anything until it's handed over to the subcontractors, and then we'll coordinate it from there. There was a Navisworks lesson learned meeting that we had with project teams, and I know I'm breaking all the rules of PowerPoint by throwing up all these words, but I really like the minutes, so I won't go over all of these. But the best things that project teams can do are all right here. We have these saved on share file. I can distribute these as well for interested project teams. But the biggest one is BIM needs to be all or nothing. There were jobs in the past that were coordinated with mechanical and electrical, but not plumbing. And, you know, the model looked really nice, and then plumbing came in and just ruined, just busted through everything. We're like, well, there was no point in having these coordination meetings or modeling. So that was the biggest takeaway from that. And also having our superintendents and our PMs available at our BIM coordination meetings is huge. It's like also little to no point in having it without them. Or at least, you know, so that we can all be on the same page and make sure that it's constructible and can actually work. So. All right. Well, thank you all for sitting through that. Are there any questions?